Okay, this is section 4.4. We've been working through different techniques and methods for solving quadratic equations. In this particular section, we're going to be discussing the method called the square root property. But before we get to that, we need to talk about what complex numbers are and how to simplify them. Okay, when you hear the phrase complex numbers, that is also referring to what are known as imaginary numbers. So these two words or terms can be used interchangeably. Okay, what happens when a square root is squared? Okay, so we want to think about when you take a square root like the square root of 8 and you square it, multiply it times itself, what actually happens to that? Well, if we were to go about this the long way, we would multiply these two 8's together and say that we would get the square root of 64. And then we know that the square root of 64 is actually 8. Okay, and so kind of a shortcut here is anytime you're squaring a square root, essentially whatever the initial number was underneath the square root, that is in fact what the answer is. So if you were to take the square root of 3 times the square root of 3, the answer would just be 3. We're kind of bypassing that middle step there where it would become the square root of 9 and then ultimately turn into the number 3. Okay, so we're first just going to discuss sort of how to simplify radicals, and then we're going to move into what exactly complex and imaginary numbers are. When you simplify radicals, such as the square root of 18, what we're not wanting to do is we're not simply wanting to type this into our calculator and record some type of a decimal. Okay, we want our answer to have a square root symbol in it unless it is a perfect square. And so what you would do, and I did part of the work here for you, I just didn't quite finish off the end of this problem, you would take the number underneath the square root and you would factor that number down into prime numbers. Okay, so for instance, the number 18 can break down into 2 times 9. We can break down the number 9 into 3 times 3. And so that's where I got 1 2 and 2 3s for 18 here. Okay. The next thing you would do is instead of drawing one huge square root symbol over top of those factors, you would assign an individual square root symbol for each of the separate factors. And then you would examine and say, okay, right here's a situation where I have a pair of identical factors. So when you have a pair of square roots, in essence, what you're doing is what we did up here at the beginning. This means that we are squaring the square root of 3, which we know that would simply turn into the number 3, but then we still have this extra square root of 2. Typically, it is best when you write your answer, if a number is not underneath a square root symbol, that you place that in front of the square root, and we would write the square root of 18 simplified as 3 times the square root of 2. Okay, let's try another one here. Okay, let's take 72. Off to the side, I'm going to factor down 72 into prime numbers here. Okay, so I'm just going to keep going until what I'm left with are just prime numbers. I'm going to organize those underneath a square root symbol with the smallest factors first and then the larger factors last. Okay. You can just visualize that each of these would have their own square root symbol. What we're looking for is we're looking for pairs of identical factors. Okay, they have to come in sets of 2 because every set of 2 represents squaring a square root. Okay, so this means the square root of 2 times the square root of 2. We know that would result in just the number 2 now, no longer underneath the square root symbol. Here we have the square root of 3 times the square root of 3, so that would result in just a number 3 as well. But you'll notice there's this extra 2 left underneath the square root symbol that doesn't have a partner to go with it. And so for that reason, that 2 is still left underneath the square root symbol. We would then multiply the 2 and the 3 that are in front together, and we would say our simplified version of the square root of 72 would be 6 times the square root of 2. Okay. Now at this point, you have mostly just worked with what are called real numbers. Real numbers are numbers that do not result in a negative underneath a square root symbol. Okay. These, I don't know why there's a big gap here. Typically, real numbers are things that you could actually identify or point to on a number line. Okay, real numbers. Okay, at this point, every number that you've worked with, we would consider that to be a real number. If you had a number line, you could point to a decimal or wherever that would fall. Even things like 6 times the square root of 2, if we did type that into the calculator, it does represent a decimal. We could roughly locate where that would fall on the number line. Okay, however, an imaginary number is when we really can't identify where that would be located on a number line. Okay, how you identify what an imaginary number is, or the characteristic of an imaginary number, is when you have a negative number underneath a square root. Okay, now we have a special symbol that we use for the square root of -1, and that is a lowercase I. Okay, so you might see imaginary numbers as a 6i, a -2i, an I times the square root of 3. And when you see that I there, it means that the I is representing a square root of a -1. Okay, so let's do the same thing we did up here where we were simplifying these radicals, only now we're going to do it with these radicals, and you'll notice what these have in common is now we are taking the square root of a negative number. Okay, so again, I would encourage you at the beginning to take your number, we'll just take 27 here. We're going to factor 27 down into prime numbers, and then we're going to write this. Now keep in mind, this is a -27, so I'm going to use -1 as one of my factors, and then there will be 3 3's as the other 3 factors. Okay, what we're on the lookout for is we're looking for any pairs of identical factors. So I do see 2 3's underneath there. So I'm going to circle those 2 3's, and I can cross them off, and I can place a 3 all the way out in front of the square root symbol, because we were saying that anytime you square a square root, square root of 3 times the square root of 3, you get 3. Okay, now, here's one rule with imaginary numbers. We never actually want to leave a -1 underneath the square root symbol. We always want to express it as an I. Okay, so next to this 3 that we have here, we're going to put an I that is representing the square root of -1. Okay, so in all actuality then, after I've replaced that with an I, the only thing that I have left underneath my square root symbol is this extra 3 that didn't have a partner. Okay, and this would be then my simplified answer for this. Okay, so very, very important to never leave a negative number underneath a square root symbol, but instead express it as the letter I. Okay, so we're going to take the number 216. We're going to break 216 down into any two numbers that multiply to be 216. And we're just going to continue to break those numbers down until we are just left with prime numbers only. Okay, you can do this a variety of ways. But keep in mind, this 216 is negative, so -1 is definitely one of my factors. And then I believe we're going to have 3 2's followed by 3 3's. Okay, I'm going to go through, I'm going to circle pairs of identical factors, and I'm also going to circle that -1 underneath the square root, because I know I want to express that as an I pulled out in front. So my square root of 2 times square root of 2, that's a 2. Square root of 3 times square root of 3, that's a 3. Square root of -1, that's an I. Now look at what we're left with. We have an extra 2, and we have an extra 3 left underneath the square root symbol. Those are going to get multiplied back together and form a 6. And I technically should go ahead and multiply this 2 and that 3 together in front, so that my answer is 6i times the square root of 6. Okay. Okay, one last one. Or actually, if you kind of got the gist of that, I think we'll go ahead and skip example C here. Okay. Let's go ahead and take a look at knowing that when we square a square root, we really just get the number that was originally underneath the square root symbol, and use that same logic for what you think we would get if we took I squared. Okay. So let's think about this here. An I is a square root of -1. So if we are going to square the square root of -1, we would get just a -1. Okay. Anytime you square a square root, you essentially get the number that was underneath the square root symbol. So that means an I squared becomes just the number -1. There's no square root symbol there anymore. Okay. Now, we mentioned that because in these next 3 problems, that's what we're going to be up against here. We are asked to take -5i times 3i. So if you just treated these i's like x's initially, of course we would say that the numbers -5 and +3 would multiply to be -15, and I times I would make an I squared. Okay. Now remember, we learned right here that technically an I represents a square root of -1. If you're going to square the square root of -1, then that's going to just turn into a -1. So this I squared turns into a -1, which means -15 times -1 turns into a +15. Okay. All right, let's try this again here. 3i times 4i would be 12i squared. I'm then going to change the I squared into a -1, and that makes my answer now -12. Okay. Now, here's where we have to be a little bit careful. We are now going to figure out what I cubed is. Okay, here's what I suggest that you do for this. Okay, if you have an odd exponent on an I would encourage you to kind of separate it into as many I squareds as you can. So in this example, an I cubed, we could separate off an I squared, and that would basically leave like an I to the first extra. Okay. We know from up here that an I squared equates to a -1, so I'm going to change that I squared to a -1, but this has to stay as an I, so my answer is technically -I. Okay, just to demonstrate for you, what if the problem was I to the 5th? What we would do is we would separate that into 2 I squareds, an I squared and an I squared, and when we put that extra 5th I by itself, each of these I squareds would turn into a -1. -1 times -1 is a +1, and we still have that extra I, so that answer would just be I. Okay? All right, so now that we've learned a little bit about imaginary numbers and complex numbers, we can now take a look at this 3rd method for how to solve quadratic equations, and this method is called the square root property method. Okay, here's how this works. Okay, what you're going to do is you are going to isolate whatever is being squared, and then you're going to take the square root of both sides of the equation. Okay, so for example, keep in mind, this is not factoring. We are not pulling GCFs out. This is a completely different strategy. When the directions, and you'll note they read here, solve by using the square root property, when it says that, this is your strategy. Isolate whatever is squared. Now I'm going to highlight what is squared in this first problem. What's being squared is the x, okay? So what we want to do is we want to get that x squared by itself. So I'm going to drag the 64 to the other side of the equation. Of course, that's going to make that a -64. Okay, then according to my process here, I'm now going to take the square root of both sides of the equation. So I'm going to take the square root of the left side, which will get the x by itself, but you'll notice now I'm taking the square root of a number that is negative. Okay, and this is why we needed to discuss imaginary numbers on the front end here. Okay, so I need to take the square root of -64. Now I know up above we were factoring down the number we had here into prime numbers, but if you know that the number you have underneath your square root is a perfect square, you don't need to mess with factoring it. We know that the square root of 64 is 8. Okay, so I'm going to go ahead and write down 8. But here's the issue. I have technically a -1 underneath the square root symbol. So I don't want to leave that there. I want to express that as an I. And then finally, anytime you are solving equations and you do take the square root of both sides of an equation, this is when you should put a plus or minus in front of your answer. There are technically two answers. Okay, let's try this again here. I'm going to just highlight what's squared in the second example, which again is simply the x squared. And then I'm going to gradually get it so that the x squared is the only thing that is on the left side of the equation. That's what we mean when we say up here to isolate whatever is squared. Okay, now I got rid of the 100, but I need to still get rid of this 4. So I'm going to divide both sides by 4. Now I've isolated what's squared. Now I can take the square root of both sides. And again, they gave me a perfect square here. 25 is a perfect square. So I know the square root of 25 is 5, but the 25 was negative. So I want to express that extra -1 that would have been left underneath the square root symbol as an I. And I was taking the square root of both sides of an equation. So I should put a plus or minus there. Okay. All right, let's go ahead and flip to the back here. We're going to do a little bit of the back, and then we'll finish the bottom half of these notes in the next video here. Okay, so here's what complex numbers are. Complex numbers, again, these are imaginary numbers, they can be written in the form A plus BI. Okay, A is the real number, and B is the imaginary portion. Okay, now this is going to feel a little bit weird because usually we don't have the constant first. When we put things in descending order, our variables kind of come first and then our constant terms come second. And this is a little bit different than that. Okay, so we'll look at these rules in this box here in just a minute. I want you to jump here to example 4. It really is as easy as the directions here say. It wants us to state what is the real number part and what is the imaginary number part. I'm simply just going to draw arrows here. 8 would be the real number, and the 4i would be the imaginary number. Okay, here -7 is the real number, -2i is the imaginary number. Okay, now there are some rules when you're working with complex numbers, okay, that we can see up here in the box. So I'm just going to kind of highlight the perimeter of this box. Today we're going to just discuss the first 2 rules, and then we'll save the 3rd rule for the next video here to kind of wrap up these notes. Okay, so rule number 1, actually I'm going to mention rule number 2 because this is something that we actually discussed on the front of the notes page. Rule number 2 says never leave a negative number underneath a square root. We always want to express that as an I. Okay, and that's what we were doing on the front. If we saw that there was a negative under the square root, we always pulled that out and wrote that as an I. Rule number 1 is to make sure that your final answer is always written in standard form. And by standard form, we are referring to A plus BI. Okay, it's very important that the real number part is placed first, and it is completely separate from the imaginary number part that is second. Okay, so let's look at example 5 here. This really is as easy as this looks. They're wanting us to simplify these 2 problems. If you really just kind of treat the i's like x's, this can be relatively simple. Okay, what you're going to do, and be very careful here. On number 5, see how there's a plus in the middle of these parentheses? This is like you're distributing a +1 here and a +1 there, which honestly doesn't do a whole lot for you. Okay, it's not changing anything, but that's what you would do to get rid of the parentheses. And then you would proceed with combining your real number portions together and then combining the imaginary number portions together. And when you do this, make sure that you have this in the correct order. That's what rule number 1 is saying. It needs to be where the real number part is coming first. That's the 7. And then the imaginary part is second. That's the -3i. Okay, slight difference here in example B, where there is now a subtraction sign in the middle. That means you are distributing a -1 to the second set of parentheses. So that will change the signs on those 2 terms. And then we're going to do the same thing. We're going to combine the 2 real number parts together, the 2 imaginary parts together, and we're going to always make sure we put the real number part first and then the imaginary portion second. Okay, and lastly, we're just going to look at multiplying together two complex numbers. You'll notice now in example 6 that now there is no addition or subtraction sign in between the parentheses. So this would be when we would kind of use the FOIL method. We would distribute the 2 and multiply that to both of the terms, and then we would come back and we would distribute the negative I, and we would multiply the negative I to both of the terms. Okay. Now, your answers, your final answer should always look like a binomial. Okay. So as I go to simplify this, it feels like these middle two terms I could combine together as a 7i. But gee, this doesn't have the feel of just two terms, a real number part, and then I've kind of got both these terms have i's in them, but one has an I squared. Okay, remember on the front, we said if you have an I that's squared, that actually turns into a -1 because that's squaring the square root of -1. So this part right here, I'm going to change that to a -1, so that what I really have is I'm taking this -5 and I'm multiplying it times a -1, which is going to change that -5 into a +5. And now I have a real number part here, a 6, and a real number part there, a 5, that I can combine both of those parts together into an 11 plus 7i. Very important that you're placing the 11 first and the 7i second. Okay, I'm just going to go ahead and quickly write down the work for this last part here so that you have that here in your notes. Okay, you would FOIL together. Okay, the last term here is going to be an I squared. You can combine these middle two terms, but then we want to change this I squared into a -1, which changes that +8 into a -8, and then allows us to combine these two real number parts together into that. Okay, this is a great place for us to stop. Your assignment is from the textbook. It's these problems plus I want you to add these 3 problems onto this assignment.